Hello everyone, thanks for joining in. In this quick demo, we will show you the integration between SageMaker Studio Notebook and AWS Glue, which allows you to have an unified and seamless experience in processing data and training any machine learning model. I am Suman Devnath. I'm a principal developer advocate for data engineering at AWS. Before we jump into the demo, let us define the problem statement. Let's say we are given a project to build a machine learning model which can help to predict the nitrogen dioxide or NO2 concentration level in the city based on that city's weather conditions. So the input data would contain information like mean temperature, max temperature, minimum temperature, and so on. And finally, we need to build a machine learning model which can predict the NO2 concentration level. But the input data is not cleaned, and the data is coming from two different sources. We will see that very soon in the demo, but we have one data set which contains the weather information, and we have another data set which contains the NO2 information. So before we proceed with the machine learning training, it is important for us to process, clean, and finally merge these two data sets so that we can make use of that for our machine learning training. So these are the two tasks we have in our hand. First, to clean the data, and we will use some tools like or frameworks like Apache Spark and Pandas. And second, to use that clean data for building and training the machine learning model. And one of the services which can help you to do the cleaning and processing of the data is AWS Glue. While we can do this with Amazon EMR as well, but today we are showcasing this with Glue for folks who want a serverless experience. And similarly, for machine learning training, we can use Amazon SageMaker. But since these two are two different services which solve two different problems, and they are mostly used by different personas. For example, AWS Glue is mostly used by data engineers, and Amazon SageMaker is mostly used by ML practitioners. So we needed some integration such that an ML engineer or as a data engineer, you do not have to hop across two different services, and you don't have to think about the access, credentials, and all of that. And this is exactly where SageMaker Studio comes in. It provides a fully integrated IDE for machine learning for all of your needs, starting from data preparation to model training to monitoring, and all of this under one single web interface. You can use SageMaker Studio's notebook capability as a unified tool to process your data as well as for your training of your machine learning model. The integration between SageMaker Studio Notebook and AWS Glue interactive session allows you to have a unified and seamless experience in processing the data and training the machine learning model. And this is exactly what we are going to see in the demo, where we will emphasize more on this integration and showcase its benefit. All right, enough of talking. Let's jump into the demo and see all of this in action. I have already logged into my AWS account, so let's click on Amazon SageMaker and go to the dashboard. As you can see, I already have a provisioned domain ready here with a SageMaker Studio user. I will add a CloudFormation template in the GitHub repository, which can help you to create the same environment like this in your account so that you can follow along after watching this video. I'm going to open this Launch App selector and open a SageMaker Studio Jupyter Lab in a new tab. The first time a user launches this Amazon SageMaker Studio, it will take a few minutes to load as it needs to pull the container for that particular user. But once you are done with that first time launch, it will launch pretty much quickly. So as I have logged in some time back, it is pretty quick for me. But if you are doing it for the first time, it might take few seconds. So this is the landing page of SageMaker Studio IDE, and on the left hand side you can see the user directory, and there are two notebooks which we are going to use for this demo. And if you go to the home tab on the left, you will see different options like data, AutoML, experiments, notebooks, and so on. So this gives one single unified view, as we were talking about a while back, for all of your need around machine learning. So let's go back to the File Explorer and open the first notebook called Data Processing Using Glue. The integration of Glue with SageMaker Studio is pretty seamless. All you have to do is to go to this top right panel and select the right image and right kernel. If we check this image option, we will see many different options. And we need to select the Spark Analytics as an image and kernel as Glue, PySpark, and Ray. We are going to use Spark for this demo, but we have recently added the support for Ray as well, which is another distributed computing framework for data processing and machine learning. So once we select this kernel, we can leverage the AWS Glue interactive session right from this SageMaker Studio notebook with Spark or Ray as a backend. And for this demo, I'm going to use ml.m5 as the instance type and click on select. So from an architectural standpoint, we are here. So as a data engineer or a data scientist, we are interacting with this SageMaker Studio notebook. And by selecting that Spark Analytics kernel, we can now use AWS Glue interactive session under the hood for our data processing task. And once that is done, we will later use SageMaker for training and deploying the model right from this SageMaker Studio notebook. So this is the problem statement which we have already covered a while back. So let me straight away jump into the code. As we know, we have two datasets. First, the OpenAQ physical air quality dataset. This dataset contains city-wise air quality data from different sources all across the globe, which includes the NO2 information. And the second dataset is the NOAA Global Surface Summary of the Day dataset, and this contains the weather recordings from over 9,000 stations spread across the globe. If you haven't seen this before, both of these datasets are coming from the registry of open data on AWS, which contains some awesome real-world datasets. Okay. So let's get started. First, let me show you this. Let me open AWS Glue in a separate tab. Let me go to interactive sessions on my left. And as you can see, we have no active Glue interactive sessions at this moment. And if we now go back to our notebook and run this magic function called stop sessions, it will say no current session. And if you would like to know what are the other magic functions you can use, you can just type %help. And it will show you all different options, like how you can specify your region using the region command, then things like idle timeout, which enables you to set the ideal timeout for your Glue interactive sessions. And then you can even specify you want to use Ray or PySpark in your interactive sessions. You can also define the number of workers that you want in your serverless compute. And with that, let us set few configurations for our demo using few of these magic functions. And here I am setting the Glue version as I want, the number of workers that I want, which I am setting it as 50, and the ideal timeout. I'm also installing SageMaker as an additional module, and I will explain you this little later as I go along with this demo. But for now, just remember that we are setting this configuration which will install SageMaker as an additional package. So if we now go back to the UI, we will see there is no active interactive session. But the moment I run the first computational cell, like here we are trying to print the Spark version, it will create a serverless Glue interactive session under the hood, which should get reflected in the UI as well. And as we can see, it's waiting for this session to get provisioned. And now if we hop on to the UI and let's hit refresh, we will see that there is a session here as well. So this might take a couple of minutes to get ready. So let us wait for a few minutes to get this provisioned. And as you can see now, it's up and ready. So we can go back to our notebook. And as you can see, it has printed the Spark version as version 3.1.1. Okay, so now that we have our Spark session ready, we can start preparing and cleaning our first dataset. So first, we are opening this single gzip JSON file and reading the schema from that. And then we are going to take that schema and use it to read the rest of the data from the open AQ dataset starting from 2000 up to the current time. We can see first couple of rows of this data which seems to have many different columns. But the columns that are important to us, which we are going to use for this demo, are the city column, the date column, and the parameter column. Since this dataset have data from many different cities, let us scope this demo down to only one of those cities, which in this case is Boston. But when you are trying out in your environment after watching this video, you may like to pick up any city of your choice. So here we are filtering the data for the city of Boston and the parameter as NO2. We are creating a new column called year, which we are extracting from one of the existing date column. And once we have this data set specific to Boston, we are going to group this data by date by taking the average of NO2 value across every single day. And this is where we are going to leverage the power of 50 workers under the hood, which is coming from the Glue interactive cluster. And this filters our data from millions of rows to a couple of thousands. Now this transformation might take a couple of minutes, so let's wait for this to finish. Okay, so it's now finished and we now have this smaller data set. Now here we take the year min and year max of our NO2 dataset, which looks like roughly around 4 years, starting from 2019 to 2023. And the reason we are saving this start and end here is because when we go ahead and start processing our second dataset, which is the weather dataset, we can read the data only for this duration. So basically what we need is we need the data for common dates from both these datasets. With that, let's now load the second dataset. And we will do something similar as we did earlier while reading the first dataset. We are going to read a single file so that we can identify the schema, and then we are going to use a bounding box here to scope that data only for the Boston city. And then we will go through the year range using those two variables, year min and year max, which we have saved a while back. So ultimately, we are reading the weather data for Boston City starting from 2019 to 2023. So while this is running, let us go through a couple of things which we are doing here. As we read the data, we are casting a couple of columns to their proper types. and then we filter it based on the bounding box right here. We are also renaming few columns. So in this data set, max is max temperature, min is min temperature, and so on and so forth. So we kind of renaming some of these columns just to make them a little bit more clearer as we read the data. And lastly, we are also doing some additional data cleansing. In this data set, these different columns, as you can see here, if there is no reading for these columns, they are represented by these specific numbers. And that can make the data a little bit tough to work with. So what we are doing here is we are taking those columns and replacing them with null values when we see these values in that column. So now we are ready to marry these two data sets. Let's take a final look at both the data frames, one which we processed earlier, that is the NO2 data frame, and the one which we have just processed, that is the Boston feature data frame. And as we can see now, both of them looks good. So now let's perform the join transformation based on the date column. So this is the final data set which we can now use for building and training our machine learning model. But before that, let us save this data on S3. And this is the end of our data processing and cleaning stage. At this point, as a data engineer, in most of the cases, our task is over. We clean the data, we process the data, and we have ultimately saved that processed data on S3. And now it's up to the machine learning engineer to take things off. So at this point, we can perform the machine learning training via two different ways. One, we can create a new Jupyter notebook and start the training job there. And another way would be to stay on this Glue interactive notebook and initiate the training job. And we can do that because if you remember, when we instantiated this interactive session, we have configured to install SageMaker Python package via the magic function. And if I scroll up, we can see that as well. While we offer both the options to proceed for your machine learning training job from here, we recommend you to perform your machine learning training and deployment in a separate Jupyter notebook, as it allows you to leverage other features and functionalities of Amazon SageMaker. So at its core, we recommend you to use Glue for data processing and cleaning, and SageMaker for rest of the things, like for machine learning training, deployment, and monitoring. So let me open the second notebook which I have for the machine learning model training and deployment. And here, if you see, we are using the data science kernel, unlike the previous case where we used the Spark Analytics kernel to make use of Glue. First, we are importing few libraries which we would need, and then we are loading the processed data in this variable called processed dataset. This is the same S3 location which we had used to save the processed data after processing it using Glue. Now let's look into the data which we are going to use for the training. And if you notice here, we are seeing a nice little visual distribution of the data in the notebook itself for all the columns. We can always look into this data as a standard pandas table by just clicking on this tab. But the reason we are seeing these visual charts as part of the data frame is because of the fact that we are using SageMaker Data Wrangler here. It's our built-in data preparation capability which helps you to accelerate your machine learning development experience. So in this section of the code, as a first step for machine learning training, we are splitting the data for training and testing. And as you can see, for training, we are going to use the data till 2022, and for testing, we are going to use the data that we have for 2023. And finally, we are just printing out first few rows of the training data after splitting. Next, we have some helper function which we are going to use later on at the time of inference. And now we can train and deploy our machine learning model using SageMaker. So here I am just starting a linear learner training job using SageMaker, which might take a couple of minutes to complete. And one thing to note here is that here we are using spot instances for training, which will save some cost for our training job. And it seems the training job is over, and if I scroll down, we can see that just because we have used spot instances, we could save more than 50% of the cost. So now that our training job is over, we can deploy our model using one single line of code using the deploy method. And this will go ahead and create an endpoint in SageMaker for us with the results of that training job. So this might take a couple of minutes, so let's wait for this deployment to get over. So this is pretty awesome, and one of my favorite thing about SageMaker, especially as a data engineer, that it makes it so easy to take something from data processing to data cleaning to machine learning training and deployment all from one single interface. And finally, we can check few of the performance indicators about this model. Things like RMSE score or root mean square error, variance score, etc. by testing our model on the test data. One more thing I wanted to show you is how you can schedule your data processing tasks seamlessly. For that, let me go back to the first notebook. So here you can go ahead and schedule this notebook as a scheduled job with just one click of a button. We can simply give some job name and set some schedule and click on create. And that's it. So it will perform this entire pipeline as per your schedule. I'm not going to create any schedule, so let me click on cancel, but you can schedule this whole pipeline based on your business requirement with just one click of a button. And lastly, once everything is done, you can stop this session using the magic function %stop session or even restart this kernel. It will terminate the Glue interactive session under the hood. And we can see that in the Glue UI as well. But in case you forget to stop the session, that's fine as well, as there is a Glue setting called idle timeout that will automatically stop the session once it reaches the idle timeout. That's it. So in this demo, we learned how you can leverage SageMaker Studio integration with AWS Glue to process the data using Spark and then train and deploy the model on SageMaker all from one single interface. If you would like to go over this demo in your environment, you may like to visit this GitHub link which contains this notebook as well as other relevant information. Thank you.